In this lecture, we are going to cover 3 important flow control statements in Python: break, continue, and pass. These statements give you more control over your loops, allowing you to modify the behavior of your loops and conditionals to suit different scenarios. Let's start with the break statement. I'll create a file and name it breakexample.py. In the file, I'll add a simple for loop. I'll say for num in a range of 10, print num. If I run the code, obviously it prints from 0 to 9. Now let's add a break statement. The break statement is used to exit a loop entirely when a certain condition is met. This can be particularly useful when you're iterating through a loop, but want to stop it once you achieve your desired result. For example, if you're searching for an item in a list and find it before the loop ends, you can use break to exit early, saving time and resources. After the print command, I'll add if num equals 5, break the loop. I'll execute it. This time, it prints from 0 to 5 because once the condition is met, the loop exits. Therefore, there is no chance to print the rest of the range. Here's an important note. The code before the break statement will always be executed as long as the loop continues to run. Let's highlight that this line comes before the break. And I'll add a similar line after the break. Anything after the break statement inside the loop will be skipped once the break is encountered. Let's run the code to see the outcome. As you can see, for iterations 0 through 4, both the before and after print statements are executed. However, when the iteration reaches 5, only the code before the break is executed. The break command terminates the loop, so we don't see the after print for 5, nor anything for iterations 6 through 9. Now that we've seen how break can stop loops entirely and affect the code after it, let's move on to the continue statement, which allows for skipping specific iterations. The continue statement skips the current iteration and moves on to the next one. It doesn't stop the loop, but it allows you to skip over certain conditions within the loop. Let's see an example. I'll create a file called continueexample.py. For num in a range of 10, print num. I'll check if num is an even number, so if the remainder when num is divided by 2 equals 0, continue. Therefore, the loop will skip printing the even numbers and only print the odd ones. Let's test it. And as you can see, only the odd numbers are printed. Now, just like in the break example, I want to check the execution of the lines before and after the continue command. Again, the code before the continue statement will always be executed. However, anything after the continue inside that specific iteration will be skipped. Let's run the code and see. The before lines are all executed, but the after lines are only executed for odd numbers. Because when it encounters an even number, the continue statement causes it to skip over the print statement that follows it, but the code before the continue is still executed. While continue and break affect the loop's flow, the pass statement, which we'll cover next, acts as a placeholder for future code without interrupting the flow. The pass statement is often used as a placeholder in your code. When you use pass, it tells Python to do nothing in places where you might plan to add code later. Regarding the before and after drama of the pass statement, the code before the pass will execute as usual, and since pass does nothing, the flow continues as if the statement wasn't there. Therefore, the code after pass will execute without any disruption. Let's quickly verify it. I'll create a file called passexample.py. In the file, I'll write similar lines of code to test the same example for the pass command. And then I'll execute it. This time, when the number 5 is reached, Python will do nothing and just pass by it. The flow of the loop remains uninterrupted, and both the print statements before and after the pass will execute as normal. That's it for break, continue, and pass statements. These simple yet powerful tools allow you to control your program's flow inside loops and conditionals. Whether you're exiting a loop early, skipping specific iterations, or creating placeholders for future code, these statements help you manage the logic of your code effectively. Always remember that the code before the statement will execute, but the code after may or may not, depending on the behavior of the statement.